Hello, everyone. Welcome to our weekly series where our students showcase the progress of having their names published in international journals. Today, we have with us Deba Chandan, who has published the paper titled Improving Construction Efficiency with Artificial Intelligence, Automated Bar Bending Schedule Generation Using Image Processing and Optical Character Recognition. But before moving forward and having a conversation with Deba about his project and about his experience of having the paper published in international journals, let's see a very small example of how we at 360 Digit MG help our students achieve success. So, for example, we have two friends. Okay, consider them as student A and student 360. Both are going through data science curriculum or data science course trainings, assignments, everything in two different institutes. One is from XYZ Institute and the student 360 from 360 Digital Engine. Now, both of them are working on projects. One is working on dummy projects, another is working on real time projects. Another one is working on dummy projects from Kaggle, GitHub. 360 student 360 is working on projects from customers who are there, who will be having interactions with the students. Now here, the student 360 has the option of attending stand-up calls. Okay, he also has his opportunity of creating end-to-end data pipelines, deploying the code on premise as well as on cloud. So he's learning when he is working here in the projects too. Now, they're also given this wonderful opportunity where they can attend client meetings, and the icing on the cake being your paper gets published in international journals. So here we have one such student with us, Deba Chandan Mohanty. So how are you, Deba?
Yeah, hi Vipin, I'm good.
Yeah, great to hear. Could you just take us through the project scope?
So let me start off with the business problem. So, yeah. So primarily, this entails the domain of construction. So in construction industry, basically, we are having something called as bar bending schedules, which are basically when a building is created from the blueprint, a civil engineer would take out the information and put it in a Excel sheet. This information will be having basically the TMT bars, what is the diameter of the bars required, what is the length of the bar required, where it will be bent. All those information are present in this bar bending schedule. So it takes around 2 to 3 weeks for a civil engineer to create this. So here the problem was it takes a lot of time. There would be, you know, because a civil engineer is creating that, it is prone to human errors, which leads to delays in the construction and also rework of this. So our main objective in this was to minimize the time taken for creating this bar bending schedules. Constraints being because there are variations on this drawings. Many engineers will build it differently. So we have to standardize it. So that was a constraint we had. Also, if it is a complex drawing, it is difficult to interpret also. That is one other constraint we have. In this project, the business success criteria that we aim to achieve was to have this bar bending schedules being created at least 50% in the 50% of time of whatever we were creating. ML success criteria was to achieve a prediction accuracy of at least 95%. And economic success criteria, we were aiming to decrease the rework by 15% and also decrease the material cost by 15%.
It
This was
seems a very
the
interesting
business
project,
scope.
Deba. Yeah, it seems a very interesting project. So would like to know more about it. Could you just take us through the project architecture, the different models, and how was the output like?
Yeah. So basically, in this project, we were given the engineering drawings, primarily the building drawings. So we had around, for per project, we had around 2 to 3 engineering drawings. From this engineering drawings, we had to extract the portion, which was basically, let's say, foundation or roof or beams. We had to extract those areas and we had to primarily also extract the information using OCR, the length or the size of the bars. So we had used two different models actually in this, both being YOLO 5. First one to extract the portion. Basically, let's say foundation is a portion, so that entire foundation. Then from that foundation, we used another model to find out the dimensions, and using OCR technology, we had extracted those information. Okay, so for the data collection, we just annotated the parts like the foundation and the specific dimensions. And using the YOLO models, we were able to extract this. So that was the first phase. In the second phase, we had to do some pre-processing because OCR uh, basically requires your output to be in a certain format. So we had done some pre-processing of images, which we extracted from the first. Then on this OCR, extracted OCR, we um, gave it labels like it is a length or the whatever. We had given the labels for that, and that we had again we had a talk with the subject matter expert, the civil engineer. He had given us for some formulas. So we have used these formulas to again generate the bar bending schedule.
And this was the model, I guess, which was used.
Yeah. So the first one was the drawing detection, which, as I'm telling you, like the foundations and all extraction, we use this model first one. So you can see here only one class is there, that is drawings.
Mm-hmm.
In the second one, you can see there is breadth, the diameter, and length, L bar, and all. So those are the specific dimensions which we extracted from the second one.
Mm-hmm.
And here we can see, okay, can you go back to the previous one? Yeah. So here you can see we had around 99.5% of accuracy in the previous one, in the first model where we are extracting the parts. And in the text extraction also, we had good accuracies.
Mm-hmm. And I guess this is how it is being done, right?
So basically, all those text that we extracted from the second model, we had to do OCR. So we had used paddle OCR. It gave us very good result. And we had generated the text. From this text, basically, we had done dimensional calculation. This is the deployment example.
Mm-hmm.
So you can see this is an example of that specific architecture diagram that we generally get from a civil engineer. If you see the portions lower, we are having three foundation drawing from different angles. We just extract those parts, and from that we extract the information. Yeah, next, if we can go. So this is basically output of that bar bending schedule that will be generated by using our application. It takes around 2 to 3 weeks for a civil engineer to make, but from our application, it will be generated in an instant.
Right. Very interesting project, Deba. And this is the image, I mean, this is the certificate that he has received for international paper publication. And see, since you have this paper published, you also might have faced a lot of challenges while doing it. What is challenges that you've come across and how do you tackle it?
Yeah, so primarily building the logic part from the start, like how we will, achieve this, because it is from engineering drawing, we don't have labels. So how to create labels and all, we had faced that initially. Then we found out the logic. We had specific labels according to the dimensions we had labeled them. So that was one of the thing, and also this paddle OCR primarily at that time. Paddle OCR, loading the paddle OCR into a Python environment was also a difficult task to achieve. But yeah, we were able to do both of this tasks.
And any suggestions that you would want to give the students or the viewers who are watching it?
Yeah. So every problem basically has a solution. As you can see, this is a multi-layered, uh, you can say, problem.
Mhm.
Like we had first extracted the specific part, then we had extracted the dimension. So have every problem will be a problem, may it be multi-layered or single layered, or maybe more than that. We'll have to go stepwise. If we go stepwise, we'll be able to achieve any problem solution.
Yeah. Thank you for the suggestion. So, friends, a problem can be much single layered, multi layered, but going through the process and going through steps is where will help us to solve that problem. Thank you, Deva.
Yeah, thank you.
So you heard from Deva, and after hearing Deva speak about his experience of working on project and how his paper got published, okay, we have this question behind, right? Whose resume will get selected? We had this example of student A, student XYZ, and student 360. Now, who do you think, after listening to Deva speak, who do you think whose resume will get selected? It's for sure a person or a student who is studying at 360 Digital MG will be the person who's getting selected for interviews and then also getting the job, right? So it was a very wonderful discussion with Deva Chandan today. Along with that, we also want to share what we provide and what we can help you with to reach your goals. So over here, you can see that we will help you understand and learn the different phases of project methodology. You'll also understand and learn the different tools in the industry like Python, Power BI, cloud platforms, SQL. Okay. And as you've heard from Deva and so many others before him, that you also get this wonderful opportunity to work on real-time projects, which leads to the fact that you will also have this opportunity of getting your names published in international paper publications. You also have this really wonderful free tools for you to use, and this is available for everyone. Okay, it's not like only students at 360 Digit MG have access to it. Everyone who visits 360 Digit MG website will have access to mind map, ML architecture assistant, resume optimization hub, and the animated learning. Resume optimization hub is a really wonderful tool, or candidates who are looking for get into a job, they can come here into the website. Okay, insert or put in the job description as well as the resume. See how it is faring in the ATS, and that's about the products or the tools that is available. So let's see how you can contact us at 360 Digit MG. Go and visit our website at 360digitmg.com or send out a mail to us at enquiry at 360digitamg.com, or you can call in the toll free number 1-800-212-654-321. We have our offices at Hyderabad, Bengaluru, and Chennai, Hyderabad being the main branch. We also have a presence in LinkedIn, YouTube, Facebook, and Instagram. Thank you, friends. Thank you, friends, for the time being spent, and happy learning.